Welcome. In this video we're going to explore grid cutting using ZebraCut. Now, a very common application for cutting machines is to cut rectangular shapes, as many of them as you possibly can on your material. ZebraCut provides you with a tool to automatically generate such cut paths, and we're going to explore how to use it now. In ZebraCut, if you go to the Generate tab, you'll see one of the generators is grid cutting. And in grid cutting, we have the ability to create a new configuration, which we'll save here as a sample. And then we can try and edit the properties of this configuration. So let's give it a name. So we're just going to call this trial shapes. And then we're going to edit the basic information about it. And we're going to try and specify how many shapes we want to cut. So let's say we want to cut 12 columns and 15 rows, and our parts we want to cut are going to be let's say 100 mm high and let's say 120 wide. That should be well, quite a few parts. And we'll ignore all the other options from for now. We'll just go ahead with this. We can validate our options just in case you've entered like a negative size or something, but that all validates correctly, no errors, and so we can save and close that. Just make sure we saved it, and now it should appear in our list of configurations. And then every time we want to run that configuration, we just press generate, and there we go. There's our lines ready for cutting. Now there's some important things to notice about these lines that have been generated. You can see we don't have squares, rather we have lines. Now if we select all of these lines and I type into the Rhino command line up the top here, dir, it will show me the direction of all of these lines. And what you can see here is actually the lines are set up in such a way as the machine should be able to zigzag through them. So it will go starting on the line and continuously zigzag all of the way around the parts here. And that's the most efficient way in which to cut. So this will automatically cut very quickly all of these individual parts. And now when we're finished with that, we can just press escape, or we can press enter to come out of direction mode. So that's a very simple grid cutting. Let's have a look at some of the options which we also have. Now when we're editing that configuration, we can do things like put in some spacing. So for example, if you for some reason can't cut your material such that you common line cut it, as you saw there where one line cuts two parts, you can add in a gap. So perhaps we need to have like a 5 mm gap between our parts. Again, if I just save that and then if I run it, you'll see we now have lots of individual lines. Now it's important to note here that we're actually going to go through and we're going to cut through the waste here and do continuous cuts all the way across. So the machine doesn't have to cut one square and then lift, it will just do long, continuous, very fast cutting of these squares. So a very quick way to generate many, many parts. So that's obviously going to be a little bit slower because you're going to have to cut every side of a square, this one and then this one, rather than doing them both at the same time. So if you can avoid offsets, then do. Sorry, spacing. Let's put spacing back to 0 because that's going to be much, much quicker. Now, if we had more parts to cut, let's say we wanted more columns. Let's say we wanted, let's say 15, no, let's go like 30 columns, let's say. Well, before I do that, let me just try to show you something else. Let's go back to 12 columns, and now we saw that we were going to zigzag cut with the machine, but we can also go ahead and just cut in one direction. So let me just show you that. And again, if we open up this one and type in the dir command, you can see that now all the cutting will happen in one direction. So if there happens to be like a grain or a thread in your material, you can use this mode here to make sure you always cut in the same direction, so any drift or any catch on the material will always take place in one way. Obviously that's going to be slower because the machine will have to travel quite a lot more, but it is a possibility if you need to do that. By the way, with this dir command, you can of course change the directions. So you can just click on the lines and then change the directions if there's any that you really wish to be cut in one particular direction. And that works with any geometry inside Rhino. Okay, let's have a look at some more options. So we'll go back and we'll turn cut one direction off. Let's add a large number of columns, so let's say 30 columns. And now we can have a look at whether we will actually try and fit this to the machine. So the machine bed in ZebraCut is related by this orange rectangle here. If I want to only generate parts within my machine, I'm going to tick those two boxes, and now I'm going to turn the number of columns and number of rows up to be very large, such that they won't fit in my machine. So again, I'll save that, and then I'll run it, and you'll see it's only generated parts that will actually fit within the cut area. Now, cunningly, that fits exactly into my machine, and you'll find there's a blue line underneath the machine bed there. But as you can see on the right-hand side, it has stopped generating them, so they don't fit in your machine bed. Okay, let's leave fit on in the Y direction, but obviously I've got a conveyorized machine here, so I don't need to fit in the X direction, so I'll leave Y on but turn X off. Now, if I had a piece of material of a particular size, then I can do a very similar thing, but using the maximum size. So if I know that my material is, let's say, 1500 millimeters by, let's say my material is 4 meters long, 4000 millimeters, then I can essentially do the same thing again and just ensure that it fits to the maximum X and maximum Y. So again, I'll just save that, delete the previous one, and then hit generate. And you'll see here now this has stopped right here. I think maybe I don't have enough columns there. That stopped at 3 meters, 3.6 meters. But the Y, for example, has stopped. You can see down the bottom here the Y. We've stopped at about 1500 millimeters as required. Now, one thing that is also useful is if you have your material, there's no guarantee that you'll have put your material onto the machine bed exactly at 0, 0. So obviously, I mean, you can move it just in Rhino and just move it around until it's in your material, or you can use set 0 or any other way of moving the geometry to the right place. But another approach which you can do is actually specify an offset here. So if I put my offset here to say 100, then it will only start generating at that particular X and Y. I'm just going to add a few more columns onto this, and then I'm going to save that, and then I'm going to run it, and there you go. So now you can see it's offset itself from the bottom just there. Now it has still generated, I think, 1500 millimeters in the Y, and that would be corresponding to my material size. So if I just analyze distance from here to there, 1.4 meters or so. So you need to be aware of how those parameters interact, but they do allow you to set up, if you have a particular point which on the machine bed which you always put your material onto, and your materials of a particular size and length, even if it's a conveyorized roll, for example, you can use this grid cutting to generate rectangles of the correct size. And again, it's the most efficient way to be able to cut these because the machine will automatically zigzag up and down these lines, cutting in both directions, avoiding wasting time by traveling. So there we go. We have the ability to use this generator for grid cutting. It's worth saying, if you have a different shape that needs to be generated in this kind of fashion, or you have some other kind of geometry you'd like to generate using ZebraCut, do get in touch. We are able to generate new generators. We are able to create new generators for custom requirements if that's desired. Brilliant. Well, thank you very much, and do get in touch if we can help you further. Thank you.